Hey everyone, so today we're going to talk about some simple stoichiometry calculations as part of the first part of chapter 12 section 2. Today we're going to use the balanced chemical equation and molar ratios in calculations for simple stoichiometry problems, and we're going to start talking about complex ones involving mole conversions as well. We've already done the first two, so if you need help or a refresher, please go back to the first video in this unit for chapter 12. So we were talking about how a recipe can be used as a model in chemistry, where our product is the thing we're making, reactants are the ingredients that we need, and the quantities or the coefficients of our balanced chemical reaction are the amount we need for each ingredient. And together we use this as an analogy for balanced chemical reactions. So if we're going to do that, and we're going to use a balanced chemical reaction for some stoichiometry problems, a problem might look like this. How many moles of ammonia can be made from 4.56 moles of nitrogen gas? If we're going to use a balanced chemical reaction, we probably need a balanced chemical reaction. So for this one, we have diatomic nitrogen plus 3 moles of the diatomic hydrogen, making 2 moles of ammonia, NH3. The first step would be to come up with that equation, come up with the chemical reaction, and then balance it. I've already done that for you to make things simple, but you would have to do that as your first two steps. The third step, I like to underline what I have, and I have here 4.6 or 4.56 moles of nitrogen gas, okay? And then what I like to do is circle what I want in my problem, so I know what I'm trying to find as my answer. And I'm trying to find moles of ammonia, so I'm right over here, and I'm trying to get to over here. And we can use our balanced chemical equation as a map. So this is going to serve as a map for getting from N2 over to ammonia. So the next step would be to look at my flowchart. So my flowchart, this is a new one that we have here. My flowchart includes my mole conversions that we did before, but now it seems like there's two of them, and this is a little bit harder to use. But for my example, I have to look at what we have. So first thing is to what do you have? I have moles of N2, and that's over here. I have a quantity, moles of N2. And then I want to figure out where do I want to go? What do I want? And I want moles. I want moles of ammonia. So we're following this line. We're going up here to the mole ratio, and then we're going down here. So step 1, step 2, and step 3. A closer look at that gives you, after you erase some stuff, a clearer picture, and in that it shows we're starting over here. And we're gonna, first step would be to have our start, which is our number. Second step would be to come up with this ratio, which is what you want, moles of what you want, over moles of what you have. And then the last step is to find your answer. So let's go ahead and do that and use dimensional analysis to solve the problem. So I'm starting with 4.56 moles of N2. I do my railroad track. I want moles of what you want up here, and that is B in our flowchart, and moles of what you have, which is A, and that goes on the bottom. What I want is this, and what I have is this. So I have 2 moles of what I want, so 2 moles of NH3. And since there's a blank, there's no number, we know it's a 1, and it's a horribly drawn one. So let me redo that. There's a 1, and then we write 1 mole of N2. And then we solve our problem, and we should get approximately 9.12 moles of NH3. So there are 9.12 moles of NH3 in 4.5. You can make 9.12 moles of NH3 out of 4.56 moles of N2. So let's try another problem. How many moles of ammonia can be made from 23.87 grams of nitrogen gas? We're using the same equation, so our first two steps are the same, and we've done them. Our third step is to underline what you have. Usually it's going to be right with that number given in the problem. In this case, it's 23.87 grams of nitrogen gas. And I want moles of ammonia again. That's where I want to go. I want to go here. So I look at my flowchart. In my flowchart, we're not starting with quantity anymore. Okay, we're starting here with grams. So this box tells me I have my start and I have to find the molar mass of A, of what I have, before I move down to the mole ratio box. And then the third step would be to go to moles, because it's asking for moles again. So moles of what you want over here. But the important thing to know is now we get a little more complexity, and we have to find the molar mass first. So find the molar mass of nitrogen gas. Nitrogen gas, N2, 2 times the molar mass of nitrogen is 14, so that's 28 grams per mole. Then we use dimensional analysis to solve the problem. So then I start with 23.87 grams of N2. The flowchart told me to put the molar mass on the bottom, grams of N2, and then on the top would be 1 mole of N2. And then we have our mole ratio. Again, it's going to be the same. I have 2 moles of what I want, NH3, up here, and 1 mole of what I have, N2, over here. And since there's no number, we put in a 1. And then I find my answer. My answer should be around 1.705 moles of NH3. This one was a little bit harder because we had that extra step right here. But we're going to be practicing both types of problems tomorrow in class. So we began, or we should have learned how to do simple stoichiometry problems with just mole to mole conversions. We started, so that one's done. We started complex ones. We're not there yet. There's another video on complex ones, but we started talking about it and figuring out how to do mole or stoichiometry problems with that. So I'll see you all in class tomorrow. Have a wonderful night.